All right, welcome to the next topic we're going to cover, which is an extension of factoring. We're going to talk about factoring completely. And that means you want to factor and then always ask yourself, is there anything more I can do? Sometimes you will be able to factor more. Sometimes you'll be able to factor more even beyond that. So it is something you always want to check for. So let's say I have this problem. Remember that the most important thing to always look for is the greatest common factor. All right, we do have a common factor of 2x, and in time you're going to get really good at finding that. And when we divide each term by 2x, we are left with this. And if you stop there because you're thinking, yay, I factored it, that's good, but it's not factored completely. And it would technically be incorrect because there's more you can do, right? So what I want you to remember is something you don't see on this slide, but I'm going to draw it in here. That greatest common factor needs to come along for the entire process. All right, so we're here at 2x times the quantity x squared minus 12x plus 36. I want to look at that and see, can I factor further? And indeed, I can factor what you see inside the parentheses, because I can do reverse FOIL. X times x is x squared. Negative 6 times negative 6 is positive 36, and outside inside gives me that negative 12x, right? So that's why this, and I'm circling it, is my final answer, because I pulled out the greatest common factor and I asked myself, could I factor more? And what I'm circling next is also correct. But remember, it's very, very important that you bring that greatest common factor along to your final answer, otherwise it's incorrect. And if you were to check it, remember always to check, I'd first do FOIL, and then I'd multiply by 2x. If I forgot that 2x, I would not find that I had the right answer. Okay, and instead of looking for patterns, I think it's easiest just to try reverse FOIL. So the next few slides, and they're in doc sharing, go over how to use reverse FOIL, which we've really already talked about. Okay, here's another example of finding the greatest common factor, and yes, there is more you can do. And this is more the way I do it. Instead of making those charts that you've seen, I show what I've tried and what failed. Okay, and to me that works really well. All right, so the tip for factoring: if you have a common factor, factor it out, and then make sure you factor completely. I'm not going to focus on these patterns for the most part, because I think your common sense and your logic will get you through it just fine. And always check your work by multiplying. Okay, here's another one where it's not in the right order. Okay, so we got to have it in descending order, and that's what we have here. Now, here's a new twist. When you have a leading negative, I want you to factor out a -1. The reason you do that is when you do that, you have a leading term that is positive. It is really, really, really hard to factor when your leading term is negative. So if you factor out a -1, what you have is pretty simple. So you can see that factoring this, what I'm circling here, is much easier with a positive leading term. So I'll leave that for you to look at. But you can always check again by FOIL and then changing the signs of all of your terms. That's what that -1 does. Okay, even if you have two variables, it's not a problem. You're going to find when your first coefficient is not 1, in this case 6, you have some possibilities, don't you? So you have 2 and 3, 1 and 6, and then you have several possibilities for 12, and then different combinations. So the more complex we get, the more possibilities there are to test. Don't let that make you afraid. Just be ready for it. Getting the right answer the very first time is very hard to do, but trial and error will get you there. Just don't give up. Okay. So I have some more examples for you. And you can recognize a perfect square trinomial. That's great. But remember, they'll factor using reverse FOIL without you having to memorize these formulas that you see at the top. So I have them there for you. Some of you love formulas and you want to just have a formula where you can plug numbers in. That's fine. It's there for you. But your logic, the trial and error, will work. It gives you something you don't have to memorize. And the more you practice with these factoring problems, the more you'll find that guessing is more and more accurate. Okay, more examples. So I have, this is probably the slide set with the most number of examples, I think. All right, if you have a difference of squares, it would look like that, and it just means the first and last terms you can take the square root of, basically. Okay, so for example, 16x squared minus 1225 is a difference of squares, and we would factor that as 4x minus 5 and 4x plus 5. But reverse FOIL would get you that too. So many examples. Okay, more factoring completely. This one we factored out a greatest common factor of 5, and we were left with x to the 4th minus 25, which might look scary, but remember x squared times x squared is x fourth, so we're going to be okay. And we can go all the way down to 5 times x squared minus 5, x squared plus 5. Can't go any farther than that. This is just a little reminder, always look for the greatest common factor first. If there is one, factor it out. If you like the patterns that you've worked with, use them, but otherwise use reverse FOIL as your next step. If it's got 4 terms, you're going to use your grouping, and always check by multiplying. All right, these formulas I need to give you, these are sum and difference of cubes. They're here. They're also in the book. They're in our notes. They're everywhere. But jot them down, because if you have something in this form, you will need to use this formula. This isn't a trial and error thing. All right, let me just jump right to an example. If I have x to the 3rd minus 8, all right, basically you're taking the cube root of the first term and the cube root of the last term. So if you have 2 terms and you can take the cube root of both of them without having anything left over, then you have a sum or difference of cubes, in this case a difference. So in my formula right here, all right, I'll try and shade it better. A is equal to x because x to the 3rd is x to the 3rd, and this one is 2 because 2 to the 3rd is negative 8. Okay, so don't worry about the sign because the formula takes care of that. But then you're just popping everything into the formula and simplifying. So it's pretty simple. The hardest part is just realizing, okay, I have a difference or a sum of cubes. Here's a sum and a great example. All right, so there's a summary of the facts. The 2 top ones are the ones you really need to jot down somewhere. Okay, all right. The next slide you see is going to be covered next week, so I want to thank you for watching this one and ask if you have questions.